Okay, boys and girls, we are on our next assignment, which is assignment 1.4, Unit 1, Assignment 4, Algebra 2. This is introducing us to these things called transformations. What transformations are is ways that you can move a graph, change a graph. So it in essence stays the same thing, but it changes just a little bit. Now, before we get to learning how to, move graphs left, right, up, down, stretch, flip, all sorts of different things, let's understand some of the basic graphs that we might be able to see. All right. And so let's just go through basic graphs. Okay. The first basic graph is a graph of an x. Okay, if you have a singular x, example, y is equal to 2x plus 1, where you just have a singular x. In general, what does an x look like? Well, it goes through the middle, and it has a slope of 1, so up 1, over 1, and it's a straight line. This is what a graph of an x looks like. Okay, up 1, over 1, that's what a graph of an x looks like. Okay, after that, we might be introduced to a thing called an x squared, and this has a fancy name of, this is called a quadratic. An x squared is called a quadratic. And what a quadratic looks like, it looks like what is known as a parabola. So a parabola is like a U kind of looking shape that kind of keeps going out. This is a parabola. This is what an x squared looks like. Technicalities of an x squared is when you go out, they go up squares of numbers. I don't really know what I'm saying, but so, for instance, when the x is 0, the height is 0. When it's 1, the height is 1. When it's 2, it's 4. When it's 3, it's 9. So again, they go up squares. Okay? A trick that I learned a while ago is to help create a quadratic a little bit faster. Notice how the heights in between these dots. Here, the height difference is 1. So between the 0 and the 1, the height difference is 1. Between the 1 and the 4, that has a height of 3. Between the 4 and the 9, that's a height of 5. And then you go up 7, and then you go up 9. And that if you go up by odd numbers, you'll create a quadratic. So that is kind of a trick that I learned that might help you graph quadratics a little bit quicker. Okay, but anyways, that's what it generally looks like. Let's see here. A little space for myself here. Okay, next is an x to the third. And this is known as a cubic. Okay, this is known as a cubic. And so what a cubic looks like is kind of like a disco dancer. That's how I remember it. It's disco. Right smack dab is the most important piece. Just again, this is the most important piece of the quadratic, and this is the most important piece of the line. And a cubic. And what a cubic does is, again, when you go out 1, you go up a cube. So that would be 1 to the third is 1. Go up 2, then from the base height, that would be 8, because 2 to the third is 8. The same going down. You go down 1, you go down 8. Okay, that's a cubic. Okay, one that is similar to a quadratic is a square root. So technically there's a 2 that you'll never see, and this is a square root. And a square root looks exactly like a quadratic, However, it doesn't go up, it goes out. So you start here and it goes out. So again, you go out 1, 3, 5, which puts you at the mark of 1, 4, and 9. And we also have a cube root. And again, that looks like a cubic, but again, it goes out, not up. So 1, go out 1. Go 2, go out 8. Okay. I think generally they kind of stick in here. The last one that you may want to know that is also, you'll see, is a absolute value. And what an absolute value looks like is a V. So it go up 1 over 1, up 1 over 1, and it looks like a V. Okay, a page something like this might be beneficial to you, so you kind of know the general idea of how to manipulate some of these things. Because on some of the questions, they'd be like, okay, write an equation of a quadratic that is moved right 2 and up 7, or something like that. And if you just don't know what a quadratic is or even looks like, you have to know what it looks like, or you have to know what it is. Otherwise, you're automatically going to get the problem wrong. So you kind of have to know, okay, what a quadratic is, and then how to manipulate it. Okay, and these manipulations, like, hey, I want to move it right 2 and up 7, are called transformations. Okay, let's talk about transformations. Okay, first and foremost, what you're going to be doing is you're going to be given what's called a parent function. So here, let's start with a quadratic. Here, this one's pretty decent. All right, so a quadratic. And so what a quadratic, just base equation looks like is you have the vertex, and then you go up 1, up 3, up 5, up 1, up 3, up 5, and you make this gross. Something like that. Okay, so you make this picture. And this is a quadratic. Okay, now there's different types of transformations that you can do to a parent function. All right, one transformation is what happens when I add and subtract things inside of this x. So let's say we have x minus 2. Okay, so what we did is we put a minus 2 on the inside, all right, with the x. So what I notice here is that this minus 2 is inside with the x. So because it's inside with the x, it's an x motion. That means I'm going to move things to the right, or I'm going to move things to the left. Okay? And if it's in with it, you do the opposite of what you would think. So, like my mind, if I see a minus, that probably means I'm moving left. but that is not correct. If it's in with it, you do the opposite. So this would be a right 2. So it's an x motion. X is the x-axis, so it's the side-to-side motion, and it would be right 2. So what would an x minus 2 squared look like? It would look like this. So you take the parent function and you just move it right 2. That would be the result of that. So minus 2 means I move it to the right 2. So if it's in with the number, if it's on the inside, okay, this is an x motion because it's in with the x, and then you do the opposite if it's in with the number. Okay, now what happens if it's not in with the number? Let's say minus 3. Minus 3. Notice how it's not in with the x. So if it's not in with the x, it does exactly what it's supposed to be doing. But notice how this is not an x motion. So that implies that this is a y motion. Again, the y is up and down kind of stuff. So this is a y motion, and if it's not in a parentheses, it does exactly what it's supposed to do. So a minus 3, I see that this is a y motion. So this would be down 3. So again, if I go to my original picture, this picture would be our base down 3. So all of the points move down 3. So you take that key base point and you move everything down 3. So you take the original and you go 1, 2, 3. And that would be that x squared minus 3. So the minus 3 is not inside with the x. So that means it's a y motion, and it is exactly what it's supposed to do. Okay, here it's inside, so you do opposite. So x motion, opposite, negative, so that'd be right 2. All right. A few more things that could exist. So let me just kind of blank these out here real quick. And you can do multiple things at once. So for instance, if I say y of x minus 2 minus 3. All right, so I see that the 2 is in with the x, so it's an x motion. Left, nope, that's opposite, so that would be right 2, and then this would be down 3. So I take that base equation, I take my base picture, take this base picture, oops. And it'd be better if I knew how to work my, work my board here. All right, so sorry about that. Okay, so that is right 2, 1, 2, down 3, 1, 2, 3. And so you can do multiple things all at once. So that's right 2, down 3. Okay, other things that you might see is you might see a minus on the outside of one of these things. All right, if you see a minus, what that does is it flips it up and down about that that key point, the major point, the vertex or whatever, the center. All right, but you do all of the motions first. You do all of the motions first. So in this problem, we move it right 2, down 3. So right 2, down 3. One, up 3, 1, 1, 2, 3, up 5, 1, 2, 3, 4, 5. All right, so this would be that, just the motion. So once you get all the left and the rights out of the way, then what you do is you flip it up and down by that middle point. So it'd be 1, 3, 5 going down. And so you do all the motions, and then it would open downwards. Okay, so anything that was up is now down. So you do all of the motions, and then you flip it. Okay, there's one more thing that you may need to know, but I'm going to kind of forego teaching that right now, and it's on one of the problems, then I'll explain it then. All right, so these are all of the manipulations. So let me just go one more time what you might see. So y is equal to the square root of x, and let's say we have a minus plus 4 plus 5. All right, so the plus 4, it's in with the x, so you would think right, but that would be a lie, so you do the opposites. So the x's lie, but not the y, was the old way that I used to remember this. So the number standing alone is a y, so this would be left 4, up 5, and then the minus would be a flip-flop. So of your base equation, which would be 1, 3, 5, and this is what the x squared looks like. What you would do is you would take that important point, blue and purple, I would move it left 4 and down 5, or excuse me, up 5. So I do all the motions, and then there is a flip. So instead of going up this way, everything up is now down. All right, so I go 1, 3, 5. And that would be the picture. So do all the motions and then the flip. Okay. Let's go back here. Okay, here we go. Describe the transformations of the given. All right, so describe the transformations. So this x plus 3, the x's lie, but not the y. So this is going to be left 3, down 7. Okay, this basic picture is an x squared. So with the x, that is a lie. X is lie, but not the y. X is lie, but not the y. So this would be left 8, up 5. Okay, so here they give us a quote-unquote quadratic. And what they want you to do with that quadratic is move it right 2 and up 1. So f of x is equal to x squared. All right, so if we move this right 5, that's an x. And so right, you would think, oh, right is a positive. But again, it's a liar. X is a lie. So that would be a minus 2. That would be the right 2. Okay, x is lie, but not the y. Up 1. So that's right 2, up 1. X is lie, but not the y. Okay, again, a quadratic. They just presented you what a quadratic is. So that's x squared. So we need to go left 7 and up 1. So left 7, so that would be plus 7. So you think plus is to the right, but again, x is lie, but not the y. That would be left 7, up 3. Okay, x is lie, but not the y. If it's in with the x, it's a lie. Okay, here they give us a starting point, and this is where it could get a little bit confusing. Okay, they start us off with that, and they want us to do several different things to this. They want us to move it to the right 5 and then reflect it across the x-axis, or just think of it as a reflection. All right, so where would you do, and what would you do if this were a blank equation? What would move this to the right 5? And that would be on the inside, that would be a -5, the x-is lie. And then reflect it across the x-axis, that is implying that there would be an outside negative. All right, so what I want you to do is just literally add and subtract these things into the pre-existing formula that is right there. So here, a negative, there isn't a negative, so that's a negative absolute value x. And again, we're adding and subtracting. So the inside is a +3, and to do what I want to do, I need to -5. So 3 minus 5 would end up to be a -2. 3 minus 5. And then there's a -1 there, so it's a -1, and there, huzzah, that's exactly what it would be. So if there's existing stuff, literally just add and subtract that stuff, coming up with your result. So for instance, number 6. I need to move this up 7. So that means I would have to put a +7 on that outside. So what is this actual final function then? Well, it's x plus 3, and then -1 plus 7 is +6. Okay. So I taught you about 90% of what you need to know. Okay, you can absolutely get down the road, and just with what we learned, you can be quite successful with what you have right now. Number 7. A number in number 7 that we haven't talked about is this outside 3. Okay, we'll worry about that in just a moment. If there's outside numbers and negative signs, you have to do all of the motions first. So this is going to be a right 5, up 1. So that is what exactly we do first. We move this to the right 5 and up 1. So it's right here, so we move it right 5, 1, 2, 3, 4, 5, up 1. Okay, so we relocated our vertex of our problem. Okay, so do all of the left and rights first. And then if there's negatives and numbers multiplying and stuff like that, worry about all that junk second. Okay, so move your stuff first. So I'll come back to number 7. So for instance, number 8. Yeah, I see that there's a minus here. Yeah, I see that. However, I'm going to do all of my motions first. So I left 2, down 7 first. I left 2, down 7 first. So left 2, down 7. Ta-da. Okay, so do all of those motions first. And then I'm going to stick with number 8 here just for a second. Let's stick with number 8. And so typically this should look like this. Over 1, up 1, just like that. Okay. However, the minus means you flip it up and down. Okay, so instead of going up, it's going to do the exact same thing but go down. That's what the minus does. So instead of opening upwards like a V, this is going to kind of open downwards, kind of like the letter A. So left 2, down 7, good to go. And then it opens downwards. Okay. Now, I haven't taught you how to do this 3. If there's a number. Okay. So I did teach you about parabolas, though. Here's what a parabola is again. Okay, if this is an x squared, this has a height of 0. 1 is 1. 2 is 4. 3 is 8. Excuse me, 9. I'm sorry, I'm done. Okay, if there is a multiple on here, like so for instance here is a 3. Any of these numbers, okay, so you establish the base, any of these numbers get multiplied by this 3. It's called a vertical stretch. So 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. And so these are the numbers that you would actually have to go up from here. Okay. Or if you like my little cheating method of doing a quadratic where you just go up by odd numbers, that works as well. So anything vertical, okay, so you establish this, no matter where it is, you establish that. And so if you like the way that I kind of did it, where you go out ones, okay, so if you go out 1, you go 1, out 1, you go up 3, you go out 1, you go up 5, okay. Again, you get the same ideas, but again, you have to multiply these things by that outside number, which is 3. So you would go up 3, up 9, up 15. Okay, so again, you do all of the motion. So right 5, up 1, and then here I go 1, 3, 5. So 1, 3, 5 is now going to be, I'm going to go up 3, 9, 15. So here I go over up 3, over up 5, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm way off the map already. Go over up 3, over up 9, and then so stretches it vertically. So any changes that you make vertically, you have to multiply by 3. So again, establish the key point and then worry about like outside negatives or multiplies of 3 and things like that. Okay, create the equation. Okay, this looks like an x squared. Okay, this looks like an x squared. Okay, now what is done to this? Okay, I see that this point, the vertex, is right 1 and down 1, 2, 3, 4, 5. It's right 1 and down 5. Okay, right 1 and down 5. So right 1 is an x, So that would be -1, so that's the right one. Down 5, -5, so the x is live but not the y. Okay. It does go up 1, 3, 5, so notice that that's a 1, that's a 3, that's a 5. So that's all squared away. Okay, so nothing is stretched. There's your equation. All right, so this is an absolute value. Okay, this is an absolute value, but what is done to it? All right, I see that this is left 1, 2, 3, 4, 5, 6. So it went left 6, and notice how it got flip-flopped. Okay, it's supposed to look like a V, but this one doesn't look like a V. It looks like an A, so it got flipped. All right, so right 6 is an X motion. This is an X motion. So you do the opposite. So that would be a +6. And then I flip-flop it with an outside negative. Okay. Now, if you want to, you can use your Desmos program. Okay, you can use your Desmos. I kind of created an example here. Let's get rid of these things. Okay, so for instance, if I think the answer to number 10 is negative absolute value of x plus 6, I can check that out. I can kind of test it out to see if that's true. All right. So let's just type it in. So we go negative absolute value, which is this absolute value A here, absolute value, and that is going to be x plus 6. So x plus 6, close that absolute value, and hooray. Does that look the way that it's supposed to look? Yeah, that looks exactly how it's supposed to look. -6. Very good. Same with this guy right here. So this is x minus 1 squared. Oh, sorry. X minus 1 squared, it's that one right there, squared minus 5. Does the picture of my graph look like that? Sure does. These things look really, so you can kind of use your Desmos calculator to kind of manipulate things, see what would happen.